Hello and welcome. In this video, we're going to take another look at our fundamentals demo, and specifically, we are going to focus on how to import data from our users.csv. Now, this video assumes a number of things that you have already watched: the file reader demo video, as well as the buffer reader demo, and have been able to successfully export info to a CSV file. And so in this video, what we're going to do is focus on how to get multiple objects essentially from the file. What I mean by that is, if you notice in the file on the right side of your screen, there is individual lines that correspond to the data associated with an individual object or collected info. And the idea is that I want to be able to take multiple pieces of information and then ultimately return them to the calling function, manipulate them, etc. So the idea here is that I want to be able to open my users.csv file and simply loop through line by line, constructing however many objects I need based on the number of lines in the file. Now, we're going to take a look at a couple of different ways to do that. In this video, we're going to focus on arrays. And so the idea is that we would like to have our function use our users.csv file and simply then return an array of collected info. So let's get started. We'll go ahead and scroll down. We're going to look for our export info to CSV. And I want to take a quick second to look at it just to refresh our memory. We hard-coded our users.csv for this particular example because we felt that it was part of the system. We're going to do the same with the import. In other words, it's a dedicated file for your application. We are still going to use a java.io.file to verify that the file does in fact exist, but we are going to end up using a java.io.file reader instead of a file writer, as well as our buffered reader. In addition, unlike our import info from custom, where it returns a single object, we are going to return an array of objects. And so let's get started. First thing that we want to do is go ahead and create a function signature of a public static. And in this case, we're going to use our ee333.collectedInfo, but we are going to indicate that it is going to be returning an array. And we are going to call this function ImportInfoFromCSV, and we're going to go ahead and call this using arrays, and it will accept no input arguments. Now, as before, you'll find it easier to just simply go ahead and set up your return value. In this case, it's going to be ee333.collectedInfo. We're going to make it an array. We're going to call it results, and at least temporarily, we're just going to initialize it as null. And then we're going to return our results. Now, let's take a second just to put in text what we were describing here. Is we want to read the users.csv and turn it into an array of collected info objects. Hopefully that seems pretty straightforward. So what we want to do is we want to go ahead and declare a few variables that we're going to need. We're going to start off with a java.io.file. We're going to call this one, as we did before, our input file. We're going to have a java.io.file reader. And again, we're going to call it an input file reader. And then lastly, a java.io.buffered reader. And we're going to call this one input buffered reader. Now, from the previous videos, you probably already know or recognize that we're going to need a few other variables. Might as well go ahead and create them while we're thinking about it. One will be a variable that will allow for us to hold the contents of a line. So that's going to be java.lang.string. And we're simply going to call it a line. And then we also need the ability to hold each one of the chunks that in this case are separated by commas. So this is also going to be a string, but it is going to be an array of strings. And we once again are simply going to call it chunks. Now in the import info from custom, the delimiter, if you would, was a combination of a colon and a space. And in a CSV file, it is going to be a comma. And so if anything, this one's going to probably be a little bit easier for us to handle. We are going to essentially just have to check to see the number of chunks that we have as a result of splitting a line. And then from there, we will write our logic as to whether or not we add an element to our array. So let's go ahead and get started. We'll start off by initializing or calling the constructor for our input file. And so input file is going to be equal to new java.io.file. And in this case, we, as we said earlier, are just going to hard code the name of the file. This is where we would want to have some logic that checks to see whether or not the file already exists. And if it exists, we want to do something with it. And if it does not, we do a system.out.println. And in this case, it probably would be an error. So say error users.csv does not exist. Now, again, all we're doing at this point is just checking to see whether the file exists. It doesn't test any concurrency issues and doesn't test to see, for instance, if it's open by another application like Excel. That we are going to have to do inside of our try catch block. And again, we're just going to catch a generic exception. And at this point, then we'll just do another system.out.println. And you can decide what message that you would like to provide to the user. Again, probably failed to open users.csv. And then follow that up with the toString of your exception. So it's going to be ex toString. All right, now at this point, let's handle the branch of the try catch where we're actually then initializing our input file reader. Again, this pattern should start to look familiar. So we're going to call the constructor of the new java.io.file reader, and we're going to pass to it an object of type input or file. And in this case, it's going to be our input file. Remember that whenever you open something, you want to remember to gracefully close it. And then we also want to go ahead and use our buffered reader. And that is going to be our input buffered reader. I just noticed we have a slight typo here. We'll go ahead and change it to a capital R. And is going to be equal to new java.io.buffered reader. And in this case, then what we're going to do is we're going to pass it the input file reader. And again, we want to make sure that we gracefully close or attempt to close these buffers as well as the file reader. And we still have a warning here. This is supposed to be input file reader. There we go. And now in the middle of this is then where we're going to set up our while loop that is simply going to allow us to loop through each one of the rows in our users.csv. Now, at this point, when we were looking at our import info from custom, we initialized our results to a new collected info object. In other words, we made a call to the constructor for the collected info. Now, if you take a look at our results, you'll notice that it is an array of collected info, and about the only thing we have access to from the perspective of a field is going to be a length, and then we have some methods associated with it, but basically we have no way to adjust the size of the array. And so you've got a couple of options here. Number one, you can resize an array in Java. It requires copying essentially the contents of an array from an existing location in memory to a new location in memory. Effectively, that is going to be the equivalent of the malloc rather, and the realloc that we saw in C. Or what you can do is you can simply statically declare the size of the array. In other words, make it larger than what you would expect to ever use. Now, for the purposes of this video, that's exactly what we're going to do. And that's actually slightly problematic. You'll see why in just a second. But what we want to do is we want to set our results then equal to an array of collected info. In other words, a new array. And so to accomplish this, we've got a couple of options. We can either declare the array and initialize it to a predetermined size at the beginning of our function and arguably waste the space, or we can check to see if the file actually exists and attempt to open it, and then allocate the memory as well as initializing the array. And so the second approach would see us using this results variable further in the code inside of our try catch block. Remember that the results right now are currently equal to null, and instead what we would want to do is create a new EE333.collectedInfo. And in this case, what we would do is we would go ahead and specify an array size. And in this case, what I'm going to do is I'm just going to make it too large. I'm going to specify a 10. Additionally, what we can do is we can also go ahead and create a local variable that we hard code the value in here and accomplish the exact same thing. We could also use, for instance, a global constant for this. But at this point, then what we have is we have an array of collected info objects. And at this point, then what we want to do is we want to, again, start off with our while loop. And we're going to have a compound condition here. We're going to, again, use our input buffered reader. We're going to read a line out of the file. We're going to store it in the line variable. And while that is not equal to null, we're going to continue to loop through the file, parsing new lines into objects. All right, but before we go any further, we need a second variable that will keep track of how many we have already found. And so what we're going to do is we're going to call that one count, and we are going to set it equal to 0. And then as part of this while loop, we are going to have a second condition that says while count is less than max, and we have not yet reached the end of file. We continue to loop through the file, parsing new lines into objects. And essentially what this does is this means that we won't accidentally outgrow our array. Now, from here, it's going to be using the chunks. And so what we're going to do is we're simply going to say chunks equal to line. And again, we're going to split the line. And we are going to split it based on a comma. Now, at this point, it probably wouldn't be a bad idea to take just a second to identify how many fields of information we've got. So it's going to be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and 11. Once again, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. And so the idea here is that our line string split should return an array of 11 substrings. In other words, sections of the original string with the comma removed. And so what we want to do is we want to simply set up our logic here. So if our chunks dot length is equal to 11, in this case, we're actually going to use a little bit of positive logic. And under the else, then simply have a system.out.println with a warning that says an unhandled number of columns. And if you want to, you can simply provide then that additional piece of information by, again, either using a system.out.printf or print line, doesn't really matter. But what we'll do is we'll specify, just for a little bit of variety here, we'll do it with a print line, chunks.length, followed by a colon, and then the actual value of chunks.length. Again, a couple of different options there. But now inside of the true branch of our if statement is where we want to initialize or call the constructor for a specific element in our results array. And this is going to be results, square brackets, count, is going to be equal to new EE333 dot collected info. And at this point, then, we have an object in our results array that has been initialized. And what we can do now is we can access the individual fields by simply using the dot notation after the square brackets. So in this case, results square brackets count dot blazer ID. And again, this is where a little bit of thought will need to come in play as far as the order of the fields in the file. We said that our chunks square brackets 0, or the 0th element in the chunks array, will be the blazer ID. Remember again that arrays in Java are 0 based. And to help you see the pattern here, it's going to be results square brackets count dot first name should theoretically be the chunks square brackets 1. And at this point, through a little bit of careful copying and pasting, you can probably quickly see what the pattern is going to be. So the last name will be square brackets 2, and so on. As a matter of fact, what we're going to do, I'm going to cheat just a little bit, and I'm going to create a template for myself that I can easily update. Copy and paste this a few times. Of course, we're going to cause some errors here, but this will hopefully speed this up just a little bit. And so in order then is going to be the languages, that should be chunks square brackets 3. So again, actually, my apologies here. That is actually going to be 4. And we're going to go and shift this up here. The initials were actually 3. All right, and then continuing on here then is going to be the goals for the class, going to be 5. The goals professional will be 6. Graduation should be 7. And then after that will be the computer model, the CPU, and the memory. And hopefully we have this right. It seems like we do, because since we're doing zero-based indexing, we ended with 10. That means we have a total of 11 fields. And hopefully we have this correct. Now, we cannot forget that we must increment our count. Now, at this point, we should probably go ahead and build it just to verify that we actually have correctly written our code. And then we want to think a little bit about how we're going to return this or capture those results then in the calling function. And more importantly, what are we going to do with them? Now, before we go any further, I want to take just a second to point out that we only have 5 rows, and theoretically, our count should only ever end up being 5. However, though, we have declared our array as having 10 elements in it. So let's go up to our main, and let's go ahead and make an attempt at calling our function. And so we'll start off here. We'll have another else if, and our else if will look at the argument's length, and we only need one argument for this particular example, and that arg square bracket 0 equals ignore case will simply be the import info from custom using arrays. And if that is true, then we will again need to declare a variable within the scope of this branch of the if statement. I'm going to keep in mind that it needs to be an array. So it's going to be EE333 collected info. It's going to be an array. And we are going to call this results. And results will be equal to a call to our EE333 FundamentalsDemo dot import info from CSV using arrays. And then all I would like to do to see that our function is actually working is to do a system.out.println. And I'm going to specify that I'd like to see the length of the array. And so in this case, what I'm going to do is specify a results.length. Now, let's go ahead and build this. Let's come over to the command window. Again, Java, EE333, fundamentals demo, and we're going to pass the switch of import info from CSV using arrays. Again, probably not the best switch names, but at least they convey exactly what we're doing in light of spending time with our help. And so at this point, let's make sure that we've got this spelled correctly. Import info from CSV using arrays. Import info from custom using arrays. So it's supposed to be CSV. Go ahead and build it one more time. Rerun this, and we have a length of 10. And so you'll notice that I have, at least on the onset, no way to provide back to the calling function the size of the array that was actually used. And so in this example, we have 10 elements in our array, but we only used 5 of them. So there's a couple of ways to get around this limitation. And fundamentally, it's going to involve either figuring out a way to pass the actual number of elements in the array that were used back to the calling function, or what we can do is simply resize the array once we have finished reading in all of the elements. And so what we're going to do now is, when we're done, we have closed our input buffered reader and our input file reader, we will simply use a function that resides in Java in the system array copy that will allow for us in java.util.arrays that will allow for us to make a copy of an array. Depending on whatever the array is, you can specify the type of the array. So copy of, and we can pass then the original results array, and we can specify the actual count. So what this will do is this will reduce the array size if it is smaller than the original max. Now, note here, we could definitely do this a lot better. We can dynamically increase the size of the array as we start adding additional rows. There's another way that we're going to go about doing this, but this will allow for us then to have the results array be the appropriate size when it is returned back to the calling function. And to see what I'm talking about, we're going to run this one more time, and you'll see that now my array length is 5. Again, this is very similar to the concept of our realloc in C and C++. Now, how are we going to leverage this? Well, if you go back to main for just a second, we returned an entire results. Well, what we would like to do is to prove that each one of those individual objects in the results array are objects in themselves. And so to do that, what we can do now is we can again set up a loop. But this time, what we're going to do is we're going to use our index, or rather reuse our index variable. And it is going to be limited by whatever the size of the array is that is returned. So in other words, index less than our results dot, accidentally had a colon there instead of a semicolon. There we go. Results less than, our index less than results dot length, and then index plus plus. And then the idea here is that I want to display, using our EE333 fundamentals demo, display info function, not the entire results array, but simply a single element in that results array. So what this does is this allows for us to display a single element, or in this case, object, in the results array. And probably one more thing that would be useful so we could sort of appreciate what's going on. I'm going to throw in one more system.out.println. And in this case, I'm going to specify the index so that we can see which element in the array we are printing out. And again, I'm going to go ahead and build it. Come out here to the command window. If we don't have any problems, you should see, and I tell you what, I'm going to take 1 second before we evaluate this. Why don't we go ahead and throw in one more print line just to help us be able to read this a little better. And you can see here now that one by one, I'm picking the elements out of the array, and you can identify which ones they are by this modified Blazor ID. And I believe I just realized that in our toString, we actually have a typo that I had somehow missed in the earlier videos. We'll have to go back and revisit that. But fundamentally, you see then how we can print out then each one of the objects and the fields associated with that object. So again, as always, if you have any questions, comments, or concerns, don't hesitate to email me, and thank you for watching.